Right, the last section, chapter 6, section 6.3, is dealing with the binomial model and actually also, to a lesser extent, the geometric model. These are specific, discrete, like special discrete models that occur often and have kind of some special formulas, and we handle different, just to kind of let you know. Up to this point, when we go to our distributions, we've only done the normal distribution. We're going to do the t and chi-squared later. Those are continuous distributions. But if we go a little bit further down, we got our binomial and F and geometric and Poisson, some of these other ones. We're really just going to do the binomial and the geometric. So we're going to learn how to do some more of those CDFs. So first of all, what is a binomial setting? Binomial setting arises when we perform several independent trials of the same chance process and record the number of times that a particular outcome occurs. So the key point here is, first of all, all of it's important, but we record the number of times that a particular outcome occurs. That's kind of what really makes it binomial, I guess, maybe. The 4 conditions for a binomial setting are binary. You have to have a success. The only outcomes can be success, failure. So yes, no, 1, 2, some kind of success, failure. There can only be 2 outcomes, binary. Independent, the trials must be independent. So the outcome of the first trial can't influence the outcome of the second trial. N, the number of trials needs to be fixed in advance. So we're always going to do the same number of trials. And S, success, you have to have the same probability of success on each trial. That can't change. So sometimes we use this, the letters BINS, to help us remember binary, independent, number, and success. Are the following a binomial setting? Yes or no? Roll a die 10 times, record the number of 4s that come up. So BINS, binary. Well, either we get a 4 or we don't get a 4. So that checks. Independent. Whatever I get on the first roll shouldn't affect what I get on the second roll. We're good. N, number of trials is constant. We're rolling the die exactly 10 times and recording. And then S, the number of successes, the probability of success is the same. The probability of getting a 4 is the same each time. And again, what really makes it binomial, though, is we record the number of 4s that come up out of 10. The number of successes is what we're recording. So this is yes. Why? Because of all this crap. Number 2, a large bin of batteries has 50 good batteries and 80 bad batteries. Select 8 batteries from this bin without replacement. Record the number of batteries that are good. So this is kind of sounds binomial. We're recording the number of good batteries out of 8. So bins, binary, either the battery is good or bad, or good. Independence, I think we got a problem. Number of trials, we're selecting exactly 8 batteries. And the probability of success, I think we got a problem. Reason we got a problem on these, we don't have independence. If you get a good battery on the first pick, since we're doing it without replacement, changes the probability on the second. Also, probability of success changes. So that is not binomial. So the formulas that we're going to learn for the binomial aren't going to apply here. Roll a die and continue to roll the die until you get a 6. Record the number of rolls needed to get your first 6. So let's do bins. Binary, either I get a 6 or I don't. Independent, the first roll doesn't influence the second roll. Set number of trials, we got a problem. Probability of success is the same. Probability of getting a 6 on the same each time you roll. However, we're going to keep rolling until we get a 6. So maybe we get our 6 on the first roll. That would be one trial. Maybe it takes us 10 rolls before we get our first 6. That would be 10 trials. So we don't have a set number of trials. This isn't binomial. Also, we're not recording the number of successes in a set number of trial. We're recording the number of rolls needed to get the first 6. Just to let you know, this is actually going to be geometric. Oh, we're not there yet. Basketball player takes 8 free throws in a row. Record the number of free throws he makes in those 8. So it sounds binomial. Binary, he either makes it or he doesn't. Number of trials, he's taken exactly 8 shots. So these are the 2 that I kind of question on this one. Independence, if he makes 3 in a row, does it influence his chances of making the 4th? Or if he misses the first 2 shots, does it change the likelihood that he misses his 3rd shot because he doesn't have very good confidence, or he's not feeling it, or on a cold streak or something? This is certainly up for debate. It's arguable. If we're going to use the binomial model here, and sometimes we do, we have to make an assumption that the probability he makes any shot doesn't influence other shots, and that may or may not be true. So I'm going to say probably not. It's debatable. So a binomial random variable. So if we have a binomial setting, then the number of successes out of 10 trials is going to follow is going to be called a binomial random variable, and its probability will follow a binomial distribution. So the count x of successes in a binomial setting is called the binomial random variable, and the probability distribution of x is called the binomial distribution, with parameters n and p. N is going to be the number of trials. That's going to be fixed, right? And p is going to be the probability of success. That should be fixed as well. So these are kind of the 3 key points you need for showing your work on binomial. You need to state that it's binomial, you need to state the number of trials, and you need to state the probability using this notation. So it's kind of like the normal distribution. You need to say the mean, the standard deviation, and you need to draw the normal curve and do the cutoffs. This is kind of what you need for the binomial model. The possible values, the sample space for a binomial, are whole numbers from 0 to n. That's just kind of common sense. If you got n trials, how many successes could you get? Well, you could get 0 successes, 1 success, 2 successes, all the way up to n successes. All right, so now we need to develop the formula for the binomial model. I'm actually going to stop the video here because I want to get all of it in the next one.